All right, let's see. So we are working on using the Intercept form. This is our first day of seeing Intercept form. So a lot of us probably have not heard of it, but it is going to be one of the three forms of quadratics that we will be using for this unit. So if you're looking at the notes, you're going to go ahead and skip that first page. We're not going to be doing this nearpod activity. However, you can use it to help you identify these different equations because it gives you the answers right there. But we're not going to be doing that for today. However, we will be looking at the next page. And like I said before, we do have three forms. Of course, the first form is going to be our standard form. So get those notes in. And then the next one will be our vertex form. And that's what we have so far. Then we look at our first two key points here. The more important thing to know from these key points is that the x-intercepts are going to be P and Q, and that our intercept form looks like this equation. That's going to be the most important thing, the most thing that really matters here. So to basically kind of put that together, essentially what happens is that if I have an equation f of x, let's say, where the equation looks like our intercept form, then we know that our intercepts for our x values, right, our x-intercepts essentially, are going to be p comma 0 and q comma 0. So it may not make sense a whole lot right now. However, later on, when we actually see the problems, it'll make more sense. Okay, so just kind of keep that in mind. Then for our teacher model here, we're going to be finding the zeros of a function. It's actually very simple, not at all very difficult. But to understand that, we first need to remind ourselves that our zeros are only whenever y equals 0. Okay, so if we're looking for our x-intercept, we need to figure out when and where our function is going to equal 0 for our y values. So keep that in mind. So essentially what we're saying is that f of x needs to be 0. Well, if I have the equation x minus 1, x plus 2, then I know that f of x has to be 0 here. Okay, and that allows me to say that we are looking for the value of 0 given some value of x. Okay, but instead of thinking about this in this context, remind yourself that any number times 0 is just equal to 0. So essentially what I'm going to do is I'm going to make each individual piece, so x plus 1 and x plus 2, I'm going to try to make those equal to 0. And that's going to give me my value that I need. So essentially what's going to happen is that I'm going to take x minus 1. I'm going to put it equal to 0. I'm going to put x plus 2. I'm going to put it equal to 0. And in doing so, that allows me to figure out what value of x I need to be. And it allows me to figure out what the value is to give me that 0. So here, if I'm solving for x, I'm going to add 1 on both sides. I get x equals 1. On the right side, I get x plus 2. So I'm going to subtract 2, and I get x equals negative 2 on this side. So essentially what I'm saying here is that the value of 1, if I plug it into my equation here, I will get a value of 0 for my y. So looking back here, right, if I change, let's see the color, let's change it to a green so it's easier to see. If I put 1 into this polynomial, x minus 1, well, 1 minus 1 is 0. 0 times anything is still going to equal 0, and that works. Well, if I take negative 2 and plug it into the other equation or other polynomial, I get negative 2 plus 2, which is 0. 0 times anything is just going to be 0, of course. So there, for sure, I have my answers. And my answer will be 1 comma 0 and negative 2 comma 0. There will be instances where on a test or something like that, you'll be asked what is the value of x, and there you would say that x equals negative 1 or x equals, sorry, not negative 1, x equals 1 or x equals negative 2. And in that case, make sure that you are actually writing those down. Okay. Go ahead and take a second to do that, see if you want. Okay. If you are stuck, you can keep watching, or if you're looking to check your answers, you can go ahead and do that as well. We should have values of x equals negative 4 and x equals negative 3, which of course in intercept form would be -4, comma 0, and -3, comma 0. So make sure you have those answers. Then in the next one, we should have x equals -7, and x equals 5 for coordinate values of -7, comma 0, and 5, comma 0. There we go. Moving on. Key point 3 and 4, just like how we discussed beforehand with the other axis of symmetry equation, we don't really need it per se. However, it is still useful to kind of think about it and use it to our advantage whenever we need to. So although I'm not going to use it for this problem, I think it still is a useful thing to know. So it has its merits there. Otherwise, you don't really need it though. Well, in this graph, I have f of x equals negative x plus 1, x minus 5. I'm going to describe the domain and range, and I'm going to graph it with the zeros. Well, the zeros part should be pretty easy. I have x plus 1 equals 0, and I have x minus 5 equals 0. Well, x equals -1, and x equals 5. So my zeros are going to be -1, comma 0, and 5, comma 0. Just like that. Pretty simple. Of course, I'm looking at a quadratic equation. Here, I know everything's going to be all real numbers for my domain because I have no domain restrictions, no real life problem or situation here. Then my range will depend entirely on whatever is my minimum value or my maximum value. Well, let me go ahead and start off by graphing the intercepts. I'm going to graph -1, comma 0, and then 5, comma 0, 1, 2, 3, 4, 5, comma 0. And then I would, at this point, probably use Desmos to my advantage here, which would be the, the safer thing, the more intelligent thing to do. Just use something that you already have something available to you, and then go from there. And so you may not be able to see it, but I'm going into Desmos right now and putting in this equation, x plus 1, negative x plus 1, then x minus 5. There we go. And I find that my vertex is going to be at 2, comma 9. So there is my vertex. Now here, you're probably good enough to just graph it like that. Probably fine. However, I do recommend trying to get at least 5 points in there. But now that I'm seeing my graph on, or so you seeing my equation on an actual graph, I should see that my range is going to be everything less than or equal to, not y, everything less than or equal to 9 here. Okay, that should be my equation, or that should be my answer. Moving on, go ahead and try this CFU2 here. If you're stuck or if you're looking for the answers, you can unpause it now. That stuff. Here, I'm looking at, again, the same kind of situation here. I'm looking for the zeros, the domain, and the range. Well, the domain already, we should know, should be just all real numbers. We're not going to be doing anything with that. No real life situation or anything like that. So nothing to really report there. For my zeros, I see I have x minus 4, x plus 1. I can go ahead and solve for that. What I get is x equals 4 and x equals -1, which tells us that -1, comma 0 and 4, comma 0 are going to be our intercepts. And like I said before, the range you need to figure out from actually graphing and or using your equation to find the axis of symmetry and solving for y and all that stuff. So there is that to consider. Whenever we are solving this, I still recommend just use Desmos to your advantage. It's really just super useful and a lot easier for things to be like that. So I would just do that. But looking at our equation here, I see that the absolute vertex is going to be 1.5, comma 12.5. So if I'm kind of guesstimated here, there's our vertex. We know our zeros, -1, 0, and 4, comma 0. And my graph would look something like this. Again, try not to make straight lines. Make sure you curve into that line and such. Which of course means that our range is going to be y is less than or equal to 12.5. Go ahead and try those practice problems there. Here, we have some problems that we're looking for, and we're trying to make sure that we are getting all those different pieces there. We need 5 different ones: vertex, axis, symmetry, zeros, domain, and range. And then you need to do it for 2 problems. Okay. So in this one, we are going to do it step by step. We're going to make sure that we have our problems done correctly, but I'm looking for my key, but I'm not seeing my key anywhere. Let me go ahead and find it real quick. Okay, so found it. And I'm just going to go ahead and write in some of these answers for you. So the vertex for that first one should be 0, 0.5, comma, negative 6.25. My axis of symmetry is x equals 0.5. My zeros are negative 2, 0, and 3, 0. Remain all real numbers. My range is everything greater than negative 6.25. My vertex for the second problem is going to be negative 1.5, comma, ooh, one small thing. Hopefully, you fast forwarded it before, but I actually wanted to change this problem because it's very similar to the last one. Instead of having x minus 4, x plus 1, you have the opposite, x plus 4, x minus 1. So sorry for that little bit of confusion there. But I should have negative 1.5 and 12.5 for my vertex. My axis of symmetry is x equals negative 1.5. My zeros are negative 4, 0, and 1, 0. Domain is all real numbers, and then my range, y is greater than or equal to 12.5. Okay, simple enough. And then to make sure that I graph it mostly correctly, again, just kind of making your best guess here and there as appropriate. So 1, 2, 3, 4, 5, 6, a little more than just 6. And then my intercepts here for that first one is 3, 0, and negative 2, 0. Graph should look something like that. My second graph does go off the edge here. I should have negative 4 and 1 for my zeros. And then I should have a negative 1.5, negative 12.5, which we'll say is about there. And that is my problem. There you go. Last one we have is this model here. We're not going to follow the CFS just because we have not learned how to factor yet. And factoring is important for us to be able to do this problem, but we haven't learned how to do it yet. But just like we do before, we're just going to use Desmos, and we're going to find those 5 different pieces of information here. So our vertex is going to be 0, negative 8. Axis of symmetry therefore needs to be x equals 0. Our intercepts will be negative 2, 0, and 2, 0. Our domain is all real numbers, and then our range is everything greater than negative 8. And so if I graph this into my Desmos, I should get a graph that looks something like this one. Again, just doing our best not to have straight lines and have curved lines. Go ahead and try the CFU3. Okay, come on back if you haven't done so already. Here, I'm going to go ahead and show you the answers. We get all of our stuff from. You're just about done. Now, for the graph, it's really difficult because, again, I don't make the notes, so it's whatever problems they give us essentially. Um, so you'll notice that the graph is definitely not going to be accurate because our 0, -36 is our vertex, and it's like you know way down there because our graph only goes to -10. But of course, you can still graph the intercepts and can kind of guesstimate where you think -36 would be. So let's say it's like down here. If I were to say this is my graph, then we're going to say that's my graph. Something like that, maybe. Then last but not least, you have some of these other problems here. I'm just going to go ahead and leave a key for you, but definitely you should try these on your own. I get 2, 0, and 3, 0, 6, 1, sorry, 6, 0, and 1, 0, -2, 0, -2, 0 again, and 6, 0. That's what we get here. Our vertex for the first problem, or problem number 5, I guess, -1, -4, x equals -1, intercepts -3, 0, and 1, 0. Domain is all real numbers. My range is y is greater than or equal to -4. My vertex is -4, -9. Axis of symmetry, x equals -4. X intercepts, x is -7, 0, and -1, 0. My range, of course, is still all real numbers, and then y is greater than or equal to -9. So if I had to graph these to my actual problem here, 1, 2, 3, 4 zeros. So my graph would look something like that one for problem 5. And then for problem 6, my problem would look something like this one. So 1, 0, and then 7. My last one should look something like that. Again, I would just try this on my own first and then check your answers from there. Well, like the notes would be uploaded on Schoology, and that's where you can access all of our other notes. So make sure that you are looking for those, and that's really about it. Make sure you're doing the Excel skills. The skills are going to be due on Friday. Okay. But other than that, we are just about done. But I will see you tomorrow probably for school. If that's the case, I'll see you then. Bye bye.